Okay, welcome to my YouTube channel. This is Incan Honest, commonly known as Mr. A Plus. Okay, so with me here, we have a question on the board that I want to learn you through. And this question, as you can see, is additional mathematics question, which is driven from past paper 2, 2022 GCE. So at this point in time, I'm actually inviting all of you viewers who are writing, who are trying to prepare yourself for additional mathematics exams. I'm here for you. Okay, so let us go through the question that we have on the board. Question number 1A, solve the equation cos, open bracket, x plus 60 degree, close bracket, is equals to sine x. For the values of x in the range 0 degree less or equal to x less or equal to 360 degree. Okay, that is question number 1. Then we go to question 1B. Given that cos A is equals to 3 over 5 and cos B is equals to negative 5 over 13, where A is acute and B is obtuse, find the value of sine, open bracket, A minus B, close bracket. Okay, so this is trigonometric equations. So now we are going to see how we can solve for x within the same topic, which is trig. Okay, so let us directly go to the solutions now. Solution. So here we are saying cos, open bracket, x plus 60 degree close is equals to sine x. So now, you as a learner, the first thing that you must master there is the identities, okay? So in trig, in A level actually, we have what is known as additional angles, or other additional formulas, double angles, half angles. Double and half angles are called multiple angles. Okay, so now those are the ideas you should have for you to work out this type of problem. Okay, minus you knowing that, it means you cannot go any further to answer this kind of question. So the one that we have here, what we are going to do is we are going to interpolate this one in additional formula. Okay, so when we do that, that is when now we are going to see how we are going to solve for x. Okay, now how do we write cos? For instance, I'll put, maybe let me assume we have A here and we have B here. Cos, open bracket, A plus B, that is equals to, that is the same principle that we are going to follow for us to find that one. Okay, so we are going to say, since we have x there, so we are going to say, when we are dealing with the cos, we say cos x, cos x, cos x, then cos, what we have there is 60 degree. And remember, when we are dealing with cos, where there is plus, here we write minus in additional formula. Okay, so it will be minus sine x, then sine 60 degree. Okay, then if we had a negative there, here it will be a positive. So you should master that concept. Okay, whereby when you have addition there. When you have plus, it will be minus. When it is minus, it will be plus here. Okay, so we are going to equate with the sin x because that is the one we are given in the question. Okay, so now from there, we are going to get a calculator. If you can see, we have cos 60 there, and this side we have sin 60. So for us to know the values of cos 60 and sin 60, we need a calculator. Okay, we need a calculator that we are going to use there. Then if you are good enough, if you know the special angles, then you can just go direct. Now remember, in paper 2, we are encouraged to use a calculator, so you don't have to waste much of your time to start considering those special angles. Instead, you just get a calculator and you place direct, where you just say, here, I've just written down the one that we have here, and this is cos x, then times cos 60. So what is the value of cos 60? So we are saying cos 60. The value of cos 60 is 1 over 2. So we are saying 1 over 2. Okay? 1 over 2 minus. Okay? There we write sin x. We just bring down this one. Then sin 60. What is the value of sin 60? We still get back to the calculator and see the answer that you are going to get. Sin 60 is the root of 3 over 2. Root of 3. So, root over 3 over 2. That is sin 60. So you have seen we have simplified that. Then equals what? What do we have here is sin x. Okay? So this is the new expression that we have just come up with. So now from there, if you can look at the sine, the cos, here we have sin x, even here we have sin x. So what we are going to do is, we are going to collect the like terms, okay? So the sines will come to the left-hand side, then the cos will go to the other side, okay? So that we can simplify further. So that is the idea which we are going to employ here. So we can either transfer sin x to come this side, or this one to go that side. It is just one and the same. And what we are going to do here is, we are going to transfer this sin x from this side to the other sin x, which is a, okay? So that we can have the like terms. So here we'll write down this one, okay? Cos x 1 over 2. Then we have equals sin x. Okay, so now this one, when this negative sin x root of 3 over 2 goes, or rather crosses an equal sign, it automatically becomes a positive, because here it's a negative, so it will be plus now. Okay, yes, then over 2. Okay, so that is the way to go. That is what we are going to do. Okay, so now from there, we'll still get back to this one. We'll bring it down like the way it is. Just say cos x, open bracket, 1 over 2, close. Then this side now, we are going to factorize. Okay, so as you can see here, with the common factor in this case is sin x. Okay, because here we have sin x on the first term, even in the second term we have sin x. So the common factor here is sin x. So that is the one we are going to do what? To factorize. So we are going to say, we are going to factor out sin x. Sin x, then we open the bracket. Here, remember, we remained with 1 plus. Then this side, we remained with the root of 3 over 2 plus. Okay, that is the way to go. Then from there, I think we can simplify this one further. We can simplify this. 1 plus the root of 3 over 2. What are we going to have? Remember here, we'll drop it down. Just continue dropping it at the moment. Then from there now, what is 1 plus 1? 1 plus the root of 3 over 2. I think this one is very simple. Okay, so now for me I'll just use a calculator, but it's very simple because this is a very simple calculations that we calculate even at lower levels, grade 1, 2, 3. We calculate those where you are adding the whole number plus the fraction number. So here this is a whole number, this is a fraction number. Here you are just going to look for a common denominator, then you say that one into a common denominator, you multiply, then you add what has meant. So me, I'll just go direct on the calculator so that I can first find the answer that we need here. So 1 plus the root of 3 over 2, and the answer is 2 plus the root of 3 over 2. Okay? Okay, 2 plus the root of 3 over 2. So that is the latest answer that we have just gotten out of this. Yes, so now from there, what are we going to do? Now this time around, since we are solving for x, so we are going to divide both sides by cos x. Okay, cos x. So we are going to say over cos x, even this side over cos x. Okay, that is what we are going to have. Here cos x will cancel each other, and we are going to remain with 1 over 2. Okay, so we use this other part of the body, 1 over. So this side we have remained with 1 over 2 equals, we are saying equals, okay. So when we go to quotient identity in trigonometry, sin x over cos x is same as tan x. Okay, sin x over cos x. Remember on the identity, as I said in my preamble, that you are supposed to master the identities that are found in trigonometry if you want to be a good calculator when it comes to this. Okay, so the quotient identity here tells us that sin x over cos x is equals to tan x. So this time around we have tan what? Tan x. We have tan x. Remember what do we have there? We have 2. We have 2 plus the root of 3 over 2. Okay, that is what we have. So I'm sure you are following me step by step and see how we are progressing with our given question. So now from there, what are we going to do? Remember, here our area of interest is to find the value of x. So it means we just now want to remain with tan x as the subject of the formula. So now from there, what we are actually going to do is this one will go to the other side. Okay, this one will go to the other side so that we can just remain with the tan x. Okay, now in this case, the best way that we can go for us to remain with tan x there, we are just going to divide by both sides by what? By 2 plus the root of 3 over 2. That is the way to go. So for us to remain with tan x, it means we are going to divide by both sides here, that one, even this side, this one, okay? What do I mean? I'm saying we are going to say over 2 plus 3 over 2. So even this side, 2 plus root 3 over 2. Okay, this is what we are going to have. So here, actually, this will cancel. Okay, and we are going to remain with tan x. So tan x is equals to 1 over 2 divide by 2 plus the root of 3 over 2. Then tan x is equals to, when we calculate that one, what are we going to have? Okay, so we'll say 1 over 2, then divide by 2 plus the root of 3 over the root of 3 over 2 plus the root of 3. Okay, me, I'm using the calculator direct there so that we can find the needed answer. 1 over 2 divided by 2 plus the root of 3 over 2. Okay, so the answer is going to be 2 minus the root of 3. Okay, so that will be the new expression that we are going to have. So tan x is equals to 2 minus the root of 3. So now what do we do for us to find the value of x? Because here what we want is the value of what? X. So x is equals to we shift the calculator, shift tan. So shift. So when you shift the calculator, it will look like this. Then 2 minus the root of 3. So x is equals to, so when we shift the calculator, then we place tan, then 2 minus the root of 3, and that will give us 15. That will give us 15 degree. Okay, so having found the value of x, remember that value of x is just the reference angle, okay? Because we have been given the range. So the range is coming from 0 up to 360 degree, okay? So that means the angle that we are going to find there should lie between 0 and 360 degree. Yes, now that we have come up with the reference angle, so what we are going to do is now to consider the tan. So like the answer that we found, the reference angle is a positive one. So it means we'll go back to unit circle, okay? Where now we are going to consider where we can find the angles that we are looking for. Since the tan here is positive, so on the unit angle, or I mean the unit circle, we are going to get now the position where tan is positive, and that is where we are going to find the solutions for x. Okay, So let me just write the unit circle here. Okay, so it looks like this. Remember, in first quadrant, we said all angles are positive. Okay. Then second quadrant is only sin, which is positive. Third quadrant, tan is positive. Then fourth quadrant, it's only cos, which is positive. Okay. Now remember, I'm saying we are just going to find angles where tan is positive. So if you can say the first one, which is the first quadrant, the tan is positive there because we are saying all angles are positive in the first quadrant. So tan, sine, cos, they are all positive. So it means this reference angle is part of the answer. Okay. Then we go to this one. So the other one is this one that we are going to find. Okay. Just this one. That is what we are going to find. So now, how are we going to find? So we are going to say this angle is 15. Okay, that angle is 15. So now this is 15. So for us to know the angle from here up to here, up to here, what are we going to do? We are going to add 180, which is the straight line, this one, plus the reference angle. Okay, that is when we are going to find now the solution in the third quadrant. Okay, where tan is positive. So we are going to say tan, 180 degree, which is the straight line, then plus 15. What is the answer there? The answer will be 195 degree. Therefore, x is equals to 15 degree, comma 195 degree, and that will be our final answer. Okay, so hope you have followed my steps and actually gotten one or two things out of this question that we've found together. Thank you so very much. Let us proceed to the next question, which is question B. Okay, question B. Now looking at the space here, we have just filled in all the space. So what we are going to do is actually we'll just wrap. I'm sure you have copied this. You have copied this in your books, and it's high time we are going to wrap and use the same space for question B. Okay. Thank you so very much. So let us go and do likewise. So we are going to wrap this one. We are going to wrap. Okay, so let us go to question B. Question B says, given that cos A is equals to 3 over 5 and cos B is equals to negative 5 over 13, where A is acute and B is obtuse, find the value of sine A, open bracket, A minus B, close bracket. Okay, so let us see how we are going to work out this one. So now, the first thing, remember, you still go back to additional formula where you are going to interpolate this one in that form. Where you say sine, okay, this is solution. Sine A minus B is equals to, how do we interpolate for sine? We say sine A cos B minus, then sine, cos A sine B. Okay, so you have seen how to interpolate sine. So it's a bit different from cosine. Remember, sine, we just say sine A, then cos B, then we still maintain the operation sign which is there, minus cos A sine B. Okay, that is the way to go. Then from there, let us now see what we are given in the question. So sine A cos B. First of all, in the question we are given cos A is there, and also cos B is there. Do we have sine A and sine B? No, we don't have. So it is not easy that we can proceed here. We can only proceed once we find sine A and sine B. Now, how do we find sine A and sine B? This is what we are going to see. Okay, so when finding sine A and sine B, you have to follow one of the identities in trigonometry. Remember, in the first place, I did mention that if you want to be a very good calculator of trig, actually you need to master all the identities that are involved. Okay, now for this one, we are going to use an identity known as Pythagorean identity. That is the one we are going to use for us to find sine A and sine B. Because when finding, we are going to use this one. That is where now we are going to substitute those, okay, that we are given, including the one that we are going to find. Okay, so now let us see how we use the Pythagorean identity. So now, for us to find, since first we'll start with sine A, we have cos A here. So let us find sine A. So Pythagorean identity states that sine A squared A, or sine A squared plus cos A squared is equals to 1. You see, that is the first one on the Pythagorean identity. They are about 3. Okay, so now from there, since we are looking for sine A, so for sine A will be sine A sine A squared is equals to 1 minus cos A squared. Okay, that is what is going to happen. So this is the one we'll pick. That's the one we are going to use. Okay, so for us to find sine A, we are going to follow that expression. So we are saying sine A squared is equals to 1 minus cos A squared. Okay, now are we given cos A? Yes, cos A is there. So it is very simple for us to find sine A, because cos A is in the question there. So now sine A squared equals 1 minus cos A squared. We have 3 over what? 3 over 5. Okay, 3 over 5. Remember, there is a square there. Okay, then from there we are saying sine A squared is equals to 1 minus 3 squared is what? 9 over 5 squared is what? 25. Okay, so let us simplify that one further. Over 1 over 1. So we are saying sine A squared is equals to, here the common denominator is 25. Okay, So 25, the common denominator. Then 1 into 25 is 25. 25 times 1 is 25. Minus this minus. 25 into 25, it's 1. 1 times 9, 9. Okay? And from there, sine a squared is equals to 25 minus 9 is 16. So 16 over 25. Okay, remember here we have the square. So for us, we need to get rid of this square because what we are looking for is sine A, not sine A squared. So what are we going to do for us to get rid of this square? It means we are going to introduce the square root, okay? So we are going to say sine A is equals to the root of 16 over 25. Then sine A is equals to the root of this, the root of 16 is 4 over the root of 25 is 5. Okay, so sine A is equals to 4 over 5. So this time around, we have cos A, cos B, and sine A. So what have we remained with? Actually, we have just remained with sine B. Okay, so we are going to use the same identity called Pythagorean identity. So for us to find sine B, what are we going to do? So this is sine A. So sine B, we are going to say, I think let me fill in this space here. That's when I'll go there. So I'm saying sine, I'm looking for sine B this time around. So sine B is equals to 1 minus cos B squared. Okay? That is the way to go. Then from there, as usual, we are going to substitute sine B squared is equals to 1 minus, what is cos B squared? Are we given cos B? Yes, cos B is there. So we are saying 5 minus 5 over 13, close bracket. Then from there, sine, okay, B equals, what are we going to have there? Remember, we have a square there. There is a square for this one. So 1 minus 5 squared is 25. Negative 5 squared is positive 25. Then 13 squared is actually 169. Okay? So let us proceed. We are saying sine B squared is equals to, this time around we have 1 there, minus, we have 25, then over, we have 169. So to simplify this one, over 1. Okay? Then from there, we are saying the common denominator there is 169. So 1 into 169 is 169 times 1, 169. Minus this minus. 169 into 169, it's 1. 1 times 25 is 25 on top there. Okay? So sine B equals, when we simplify, 169 minus 25 is 144 over 169. So sine squared B squared. Actually here, we want to get rid of that square. So what are we going to do? Introduce the root there. The square root was 9. Okay, so sine B is equals to, the square root of 144 is 12 over the square root of 169 is 13. Okay, so our sine B is 12 over 13. So now, having done that, it is now very easy for us to find the value of sine, open bracket, A minus B, close bracket. Okay? So now, what has just remained here is to substitute. So let us just substitute now. This time around, we are going to substitute. the values that we have. Okay, so we have sine A. Remember in the question again, we to get back to the question. The question says there is a condition where they said where A is acute. So when we say acute angle actually, this is an angle that ranges from 0 to 89. So you have to understand that. That is acute angle. So acute angle ranges from 0 to 89. Or let me say 90. Okay? Then we also have another term which says obtuse. What is an obtuse angle? Obtuse angle is the angle that ranges from 91 to 179 or to 180. That is obtuse angle. So when we say acute angle, it means that particular angle is in the first quadrant. Then obtuse angle, that angle is in second what? Quadrant. That is very, very important for you as a learner to understand that, okay? For you to proceed. So now from there, since now that we've have interpreted this, we can easily now substitute, okay, depending on the position of those angles that we have. So sine A, remember A is an acute angle, and automatically sine in the first quadrant is positive. So sine A, do we have sine A here? Sine A, yes, it's here. We have found. So where there is that one, we are going to put this. So we are going to say 4 over 5. 4 over 5. Oh, let me say sine A minus B equals 4 over 5. Since we are saying here is 4 over 5, 4 over 5. Then times. Remember here there is a times. Then cos B. So we go now to B. Okay. So B, they are saying B is in the second quadrant, and we are with the cos. So obtuse is the second quadrant. So now B is in the second quadrant. Okay, what are we going to do? Cos in the second quadrant is negative. When we get back to the unit circle, cos in the second quadrant is negative. So let us see the cos that we are given. Okay, it's here, it's already negative. So just pick it the way it is. So it will be 5 minus 5 over 13. Then we have, what's the sign there? Minus. Okay? Again, we go to this side now. Cos A. Do we have cos A? Yes, we are given C. A is what? Acute. So all angles in first quadrant are positive. So just pick it the way it is. Positive. 3 over 5. 3 over 5. Then times. Then we go to sine B. Sine B. Do we have sine B? Yes, we have it. It's where? Sine B, we have found it. See sine A. Then sine B. Oh, it's on top. It's here. 12 over 13. So now for sine B. So B is in the second quadrant because it is an obtuse angle. So since it is in the second quadrant and sine in the second quadrant is positive, so just get it the way it is. Positive 12 over 13. Okay? Then from there, we can simplify further. So when you say 4 times negative 5, it's negative 20 over 5 times 13. 5 times 13 is 65. Okay? 65. Remember, we have a minus there. Okay? 3 times 12. What is the answer? 36. 3 times 12, the answer is 36. 5 times 13 is 65. Okay? Okay? So let us simplify. This is, I think, the common denominator just one the same. So we just add there and we pick one. So negative 20 minus 36 is negative 56. Over, just pick 165. Therefore, sine A minus B is equals to 56 over 65, or negative 56 over 65, and see the answer. And that will be our final answer. Thank you so very much for paying a particular attention, and move together in this way. Continue actually following my YouTube channel. If you have not actually subscribed to my YouTube channel, it's high time that you subscribe, then you comment, and you also share the video, so that even your colleagues who are not privileged to watch my tutorial can be able to get one or two things. Thank you so very much. Bye.